Welcome to Spring LIB.
For this problem on the topic of alternating current, we are told that for a sinusoidally driven RLC circuit to show that over a complete cycle with period t, the energy stored in the capacitor does not change, the energy stored in the inductor does not change, the driving EMF supplies an energy of a half T times epsilon m I cosine phi, and the resistor in the circuit dissipates energy a half T Ri squared. We then want to show that the quantities found in C and D are actually equal. Now, since the charge Q is a periodic function with period t, that's a function of little t plus big T, this must be the same for the energy stored in the electric field of the capacitor. So UE is a function of t plus the period. And so, therefore, the energy stored in the capacitor will not change over one period. And so the energy in the capacitor is constant throughout the period. Now for part B, we want to show that the energy stored in the inductor also does not change. Now the current I is also a periodic function of time, and so this must be the same for the energy stored in the magnetic field of the inductor. And so UV is also a periodic function of time, which means that this energy is constant over a period. For part C, the energy supplied by the EMF device over one cycle, UE, is equal to the integral from 0 to t of the power P epsilon dt, which is the current I times the peak EMF epsilon m over multiplied by the integral of from 0 to t times the sine of the driving frequency omega d times t minus phi times the sine of omega d times t dt. And so this is I times epsilon m times the integral over the period of sine omega d t cosine phi minus cosine omega d t sine of phi, all of this times the sine of omega d times t dt. And so solving this integral, we get this to be t over 2 times I epsilon m cosine phi as required. Now, in the above equation, we've used that the integral of sine squared omega d dt is actually t over 2, and the integral of sine omega dt times cosine omega dt dt is equal to 0. Now for part D, over one cycle, the energy dissipated in the resistor, UR, is the integral over the period of the power through the resistor, PR dt. And PR is I squared R, which is constant, times sine squared omega d times t minus phi. So we integrate sine squared omega d t minus phi with respect to t. And performing this integral, we get this to be t over 2 times I squared R, as required. And now we want to show that our expressions in C and D are equal, and we can see from C that epsilon m times I cosine phi is equal to epsilon m times I times VR over epsilon m, which is epsilon m times I into IR over epsilon m. And this becomes I squared R. And so the two quantities are indeed the same.